Okay, so this is 3.2b CPCTC. Okay, so what exactly does CPCTC stand for? Well, CPCTC we use when we know triangles are congruent. This means corresponding parts of congruent triangles are congruent. Right? That's way too long to write. So we use CPCTC. Corresponding parts of congruent triangles are congruent. That's something you're going to want to write down, star, highlight, circle, whatever you need to remember that. So two triangles must be proved congruent before CPCTC can be used. So I have to know that triangle ABC is congruent to triangle DEF before I'm allowed to use CPCTC. Okay, so here are some strategies for proving that two triangles are congruent. You already know the theorems, right? Angle, side, 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 angle, side, and hypotenuse, leg. But sometimes this can be helpful. So if you mark your figures systematically, so put those squares in the right angle, use the same number of tick or dash marks on those congruent sides. So if you have a triangle and this triangle, make sure that you use separate numbers, right? So 1, 2, 3, etc. And use the same number of arcs on congruent angles. So if you're going to do one, maybe do a one like that, and then one like that. Right? Make sure that's better if you want to do that like that. Trace triangles to be proved congruent in different colors. So maybe you have a shape that has a lot of different triangles in it. Make sure that you trace them in different colors and different highlighters with different pens, with different anything, so that way you can see them. And then if your triangles overlap, sometimes it's helpful to draw the triangles separately. Sometimes it's hard for me to actually see what the triangles look like when they're on top of each other. Okay, so here's our first example. So WZ bisects angle TWV and WT is congruent to WV. So we know that we always have to mark up our diagram. If you don't have one, draw one. If you do have one, mark it up. So I know that WZ bisects angle TWV. So here's angle TWV and here's WZ. So I know that this angle here is congruent to this angle here. I also know that segment WT is congruent to WV. Well, I'm going to go ahead and mark that like that. And I ultimately want to prove that TZ is congruent to VZ. So I don't know that, okay? So let's go ahead and start with our flow proof, okay? So I'm given that WZ bisects angle TWV, and that's because that's given to me. Okay, I'm also given that segment WT is congruent to segment WV, and that's also given to me. So with those, we also know one other thing. I know that WZ is congruent to itself. So I'm going to put that down here. WZ is congruent to WZ. And what's the property with that? Well, that is the reflexive property. Okay? So now that I know that, okay, I know something about this step, and this step. Well, if we look over here at our triangle, I see that I have side, angle, side, side, angle, side. So by using these three pieces of information, I can conclude that triangle TWZ is congruent. So let's see, if I start TWZ, I'm going along the 1 hash mark and 2 hash mark. So I have to start here, go up the 1 hash mark, down the 2 hash mark. So that's triangle VWZ. And that's because of side, angle, side. So I had to use all three of those pieces to get there. So now that I know that these two triangles are congruent, I can now prove that TZ is congruent to VZ. So I know that TZ is congruent to VZ, and that's by CPCTC, right? Corresponding parts of congruent triangles are congruent. So since I have this triangle congruent to this triangle, this piece has to be congruent to this piece. Okay, so that's the end of our proof. Why don't you take a minute and think about how you would prove this? If you're given that ZW is congruent to YX and ZY is congruent to WX, tell me how you could prove that ZY is parallel to WX. So take a moment, pause the video, and see if you can figure it out. Okay, so if we look at this, all right, I know automatically a few things. So I'm going to mark it up. ZW is congruent to YX, and ZY, so this guy up here, is congruent to WX. Okay, and I need to prove that ZY, okay, so where's ZY? ZY is up here, is parallel to WX. All right, so first let's start off with our givens. ZW is congruent to YX, and that's because it was given. We also have ZY congruent to WX. That was given. Okay, great. I also see something else. I see that this guy here is congruent to himself. ZX is congruent to ZX by the reflexive property. Okay. So now from here, I notice something on my diagram. Automatically, what jumps out is if I go down 1, 2, 3, 1, 2, 3, I have that triangle ZWX is congruent to triangle. Let's see. ZWX, 1 down 2. So I go 1, then 2. So XYZ is what it is congruent to. And that's because of the theorem side, side, side. So I needed this guy, and this guy in order to prove that. So from there, I know a couple things, right? Ultimately, I want to prove, so I'll do this in a different color, okay? Ultimately, I want to prove that this is parallel to this. Well, how can I do that? Well, let's think backwards, right? If that's what I want to prove, maybe those angle 1 and 2's can help. Well, see what I've just done there? I've created that Z. Since I know that triangle ZYX, so ZWX here is congruent to XYZ, I know that angle 1 and angle 2 are congruent to each other. So angle 1, let's write that back in pink. Angle 1 is congruent to angle 2, and that's because of CPCTC. Again, we've proven that the two triangles are congruent, so we can prove that those pieces are congruent. So, remember, corresponding parts of congruent triangles are congruent. Now, I can then take it one step further from there and say that ZY is parallel to WX. Okay? And I know that because two lines cut by a transversal, so alternate interior angles are congruent, the two lines are parallel. So by looking in the nifty 50, I see the reason with that on page 5, it says alternate, so that's alt, interior, angles congruent leads me to parallel lines. Okay, and that's exactly what we want to prove here. So now let's go back to example 1. There's one more thing I wanted to say. So if I think about this, right, I went to CPCTC, just like we did in example 2, once I have used this for proving that two triangles are congruent, I can use CPCTC for anything in here. I could have also proven that angle T is congruent to angle V. I could have done anything. I could even go one step farther after CPCTC. And that could be to say, I'll do that down here in blue, that segment WZ bisects segment TV. And why do we know that? Well, we know that if a line segment is divided into two congruent parts, then it has been bisected. So let's write that. So line segment divided into two congruent parts. Segment is bisected. Okay? So that would be a direct consequence of CPCTC. Okay, so ultimately what you need to think about is first prove that the triangles are congruent, and then you CPCTC, and then you can go farther if you want to or if you need to. Okay?